I am Radhakrishna, mathematics teacher. Today we are going to continue our topic indefinite integration, 5th lecture. In our previous class, we started discussing integration of irrational functions. We discussed one or two models. Let us recap. Integral of 1 by root over ax square plus bx plus c. What is the method? We have to express this ax square plus bx plus c in the form of x square plus a square or x square minus a square or a square minus x square. Then we can directly write the integral. For that we need to write ax square plus bx plus c as a perfect square by adding and subtracting some constant. Similarly, for integral root over ax square plus bx plus c, same way we have to write this in the form of integral root over x square minus a square or x square plus a square or a square minus x square, where capital X represents a linear expression in small x, capital A is constant. Then we have a direct formula for integral of root x square minus a square, root x square plus a square, root a square minus x square. Next, model 2, we have already discussed this. If the integrand is in the form of px plus q by root over ax square plus bx plus c, then we need to write px plus q as a constant a into derivative of ax square plus bx plus c plus another constant b. Then we have to separate the denominator and integrate. And we have already solved this example. Same method for integral px plus q into root over ax square plus bx plus c. We can solve this example. Integral 2x minus 1 into square root of x square plus x plus 1 dx. We need to write 2x minus 1 in terms of the derivative of x square plus x plus 1. Let 2x minus 1 be equal to a constant a into d by dx of x square plus x plus 1 plus another constant b. Now, derivative of x square plus x plus 1 is 2x plus 1, a into 2x plus 1 plus b. Now, by comparing the coefficients, we have to find a and b. Comparing the coefficients of x, 2a is equal to 2. In the RHS, coefficient of x is 2a, in the LHS 2. So, 2a is equal to 2, a is equal to 1. Now, comparing the constants, what is the constant term in the RHS, term independent of x? A plus b is equal to, in the LHS, constant term is minus 1. If you substitute a is equal to 1, we will get b is equal to minus 2. Then this integral is 2x minus 1 is a into, that is 1 into 2x plus 1 plus b is minus 2 into root over x square plus x plus 1 dx. Okay. Now, separate this into two integrals. This into this, two x plus 1 into x root over x square plus x plus 1 dx minus 2 into integral root over x square plus x plus 1. Right. Now, derivative of x square plus x plus 1 is 2x plus 1. So, if you put this as t, x square plus x plus 1 as t, 2x plus 1 into dx becomes dt. So, this becomes integral root t dt. What is the integral of root t? T power 3 by 2 by 3 by 2. So, I will write it directly, 2 by 3 into t power x square plus x plus 1 power 3 by 2 minus 2 integral, how to integrate root over x square plus x plus 1, we need to write this as a perfect square. I have already explained in many problems how to write this as a perfect square, so I will write directly. It can be written as x plus 1 by 2 whole square plus 3 by 4 dx. Now, first term as it is minus 2 into, what is the integral of root x square plus a square? Integral of root x square plus a square is x by 2, means x plus 1 by 2 by 2 into root over x square plus a square. I will directly write x square plus x plus 1 plus a square by 2. A square is 3 by 4, a square by 2 is 3 by 8 into sine h inverse x by a, x plus 1 by 2 by, what is a? A square is 3 by 4, so a is root 3 by 2. So, by root 3 by 2 plus c. Now, I hope you can simplify it. Next question, integral 1 by px plus q into root over ax square plus bx plus c. We have already discussed this model in the previous class. We have to put px plus q is equal to 1 by t. This is a standard form of the irrational function. Putting px plus q is equal to 1 by t, this whole integrand will be transformed to 1 by root over ax square plus bx plus c form. Okay. So, this example we have already solved. Now, another model, integral ax plus b into root cx plus d, integral ax plus b by root cx plus d, integral root cx plus d by ax plus b, and one more, integral 1 by ax plus b into root cx plus d. For all these 4 forms, we can substitute the term under the root as t square and make the function rational. So, standard substitution for these 4 forms is put cx plus d is equal to t square. Then it becomes a rational function. Whichever term is there in the square root should be substituted as t square. Let us solve some questions. One more. Here also we can integrate by substituting cx plus d is equal to t square. But there is an alternative method for this. I will explain later during the examples. Let us solve some questions. Integral 3x plus 2 by root 2x minus 1. What is the substitution? Put two x minus 1 is equal to t square. As usual, we differentiate it. Differentiating derivative of 2x minus 1 is 2. 2 into dx is equal to 2t into dt. 2 cancels. Next, substitute here. This integral will be integral 3x plus 2. What is the value of x? 2x is equal to 1 plus t square or t square plus 1. X is t square plus 1 by 2t. Substitute here 3 into t square plus 1 by 2 plus 2 by root 2x minus 1 is root t square, that is t, into dx is t dt. Simplify it. T cancels. What is the remaining? integral 3t square by 2 plus 3 by 2 plus 2. What is 3 by 2 plus 2? 7 by 2. dt. Now integrate it. Integral of 3 by 2 into integral of t square is t cube by 3 plus integral of 7 by 2 is 7 into t by 2. 3 cancels. Then substituting t, you will get the answer half into t is square root of 2x minus 1. So, this will be 2x minus 1 power 3 by 2 plus 7 by 2 into t is square root of 2x minus 1 plus c. Okay. Next example, integral 3x minus 4 by 2x plus 3. What will you substitute? Term under the root as t square. Put 3x minus 4 is equal to t square, differentiating on both sides. 3 dx is equal to 2t dt. Then dx is equal to 2t dt by 3. Then substituting here, integral root over 3x minus 4 is t by, substitute x here, x is t square plus 4 by 3, 2 into t square plus 4 by 3 plus 3 into dx is 2t by 3 dt. Now simplify. Numerator is 2t square, t into 2t, 2t square by multiplying by 3 inside 2t square, this 3 cancels, 2t square plus 2 into 4 8 plus 3 into 3 9, 8 plus 9 17. How to integrate it now? We write numerator as 2t square plus 17 minus 17 by 2t square plus 17. Now separating the denominator, this by this will be 1 minus 17 by 2t square plus 17. What is the integral of 1 with respect to t? It is t minus 17 into, write this as integral 1 by 2t square is root 2t whole square plus 17 is root 17 whole square. Now it is in the form of 1 by x square plus a square. What is the integral? Integral 1 by x square plus a square is 1 by a tan inverse x by a. 1 by a is root 17 tan inverse root 2t by root 17 But when we assume some linear term as x, we have to divide by the inner derivative of that x. What is the inner derivative of root 2t with respect to t? Root 2. So, here you will get divided by root 2 plus c. Now, simplify it. T minus root 17 by root 2 tan inverse root 17 by 2 into t plus c, where t is equal to root 3x minus 4. You can also write the answer in terms of t, leave the answer in terms of t by writing where t is equal to root 3x minus 4. In subjective type questions, you can leave the answer like this. Next, integral root over 1 plus x by 1 minus x. As I have told you, I will explain this method, this question in two methods. First, method 1. As we have discussed, if the integrand is in the form of root ax plus b by root cx plus d, we can put the term which is there in the denominator as t square. Put cx plus d is equal to t square. So, integral root over 1 plus x by 1 minus x dx, put 1 minus x is equal to t square. Differentiating both sides, minus 1 into dx is equal to 2t dt. Substituting here, numerator is root over 1 plus, what is x? 1 minus t square. If you substitute x as 1 minus t square, it becomes numerator becomes root over 2 minus t square by root 1 minus x is t into dx is minus 2t dt. Cancel t. Then minus 2 into integral root over 2 minus t square. 2 can be written as root 2 whole square minus t square dt. This is the standard formula. Integral root over a square minus x square dx is equal to x by 2 root over a square minus x square plus a square by 2 sin inverse x by a. Minus 2 into x by 2 means t by root 2 root over a square minus x square means 2 minus t square plus a square by 2 means a square is 2, 2 by 2 1 into sin inverse x by a means t by root 2 plus c. Substitute t as root over 1 minus x. Okay? Second method. When the integrand is in the form of root over linear term by another linear term, another method is rationalizing numerator. How to rationalize root 1 plus x? Multiply and divide by root 1 plus x. then numerator becomes 1 plus x. Denominator will be root 1 minus x into root 1 plus x, that will be root 1 minus x square dx. Now separating the denominator, integral 1 by root 1 minus x square dx plus second integral is x by root 1 minus x square. What is the integral of root 1 by root 1 minus x square? Sin inverse x. Plus, how to integrate x by root 1 minus x square? Derivative of 1 minus x square is minus 2x. So, if you multiply by minus 2 here, divide by minus 2. Then it becomes f dash x by root f x. What is the integral of f dash x by root f x? We have the formula 2 root f x. Plus into minus, minus. It will be minus half into 2 root f x is 2 root 1 minus x square plus c. Cancel 2. That is the answer. I think that method will be looking good. Answer is in a simple form. Otherwise, we have to substitute here and simplify. But both answers are looking different, but both are equal. They may differ by a constant. Next question. Yeah, same way. You can try in the same way. Next, integral 1 by ax square plus b into root cx square plus d. We have already discussed the method for 1 by ax plus b into root cx plus d, putting cx plus d is equal to t square. But when they are quadratic without x coefficient, the standard substitution is put x is equal to 1 by t. Put x is equal to 1 by t. Let us solve one question. Integral 1 by 2x square plus 1 into root over x square plus 4. Put x is equal to 1 by t. Then differentiating on both sides, derivative of x is 1 into dx is equal to derivative of 1 by t is minus 1 by t square into dt. Then that integral I is equal to in any question we can assume that the given integral is I is equal to integral 1 by 2 by t square plus 1 into root over 1 by t square plus 4 into minus 1 by t square dt. Simplify. This becomes t square by t square plus 2 and this becomes t square is LCM, but root t square is t. So, t by root 1 plus 4t square into minus 1 by t square dt. Now, you can cancel t square. Then minus integral t by t square plus 2 into root 1 plus 4t square Now, we can notice that derivative of 1 t square is 2t, t is present in numerator. So, if we can put 1 plus 4t square is equal to some u square, put 1 plus 4t square is equal to u square. Usually, we try to make the terms rational, that is why we are putting the term under the root as square of something. Differentiating on both sides, we get 8t dt is equal to 2u du. So, t dt is equal to u du by 4. Now, t dt is numerator, that is u du by 4. By what is t square? U square minus 1 by 4 plus 2 into root over u square is u. What happens now? U cancels. Now, you can cancel 4 also. It becomes minus integral du by u square plus 7, which is standard integral. You can write 7 as root 7 whole square, then integral 1 by u square plus root 7 whole square is 1 by root 7 tan inverse u by root 7 plus c. Substitute u and again substitute t as 1 by x. Then u square is 1 plus 4 by x square minus 1 by root 7 tan inverse of u is root over 1 plus 4t square, no? So, u will be root over x square plus 4 by x by root 7. So, x root 7 plus c. This is the final answer. Now, next, integration of standard trigonometric functions. There are some standard forms of trigonometric functions for which we have a standard substitution. Let us discuss one by one. Model 1. Integral 1 by a plus b cos x or integral 1 by a plus b sin x or integral 1 by a sin x plus b cos x or integral 1 by a sin x plus b cos x plus c. For these 4 forms, standard substitution is tan x by 2 is equal to t. You need to remember, whenever the integrand is in one of these 4 forms, blindly you put tan x by 2 is equal to t. Then you should be able to write the whole function in terms of t. How? You know the formula for cos x in terms of tan x by 2. If tan x by 2 is t, cos x is 1 minus t square by 1 plus t square, and sin x is 2t by 1 plus t square. So, you can convert all these functions in terms of t, okay? And when you put tan x by 2 is equal to t, we should write dx in terms of dt. How? Derivative of tan x by 2 is half secant square x by 2 dx is equal to dt, but half secant square x by 2 is not there in the integrand. So, dx is equal to, cross multiplying, we get 2 dt by secant square x by 2. Secant square x by 2 is 1 plus tan square x by 2, that is 1 plus t square. So, in all these integrals, these steps are common. Okay. Now let us solve some questions. Integral 1 by 5 plus 4 cos x. Put tan x by 2 is equal to t. Then the next step is half secant square x by 2 dx is equal to dt. Then dx is equal to 2 dt by secant square x by 2 is 1 plus tan square x by 2, that is 1 plus t square. Now substitute in the given integral. I is equal to integral 1 by 5 plus 4 into, what is cos x in terms of t? 1 minus t square by 1 plus t square into dx is 2 dt by 1 plus t square. Simplify it. If you take LCM 1 plus t square, it will cancel. Integral 2 dt by, what will get after cancellation of 1 plus t square? 5 into 1 plus t square plus 4 into 1 minus t square, that will be 9 plus t square. You can take 2 common, take 2 outside. What is the remaining? Integral 1 by 3 square plus t square. What is the formula? 1 by a tan inverse x by a. So finally you will get 2 by 3 tan inverse t by 3 plus c. Substitute t as tan x by 2. 2 by 3 tan inverse tan x by 2 by 3 plus c. This is the standard procedure. Suppose you have cos 2x here, then you have to put tan x is equal to t. Remember. Next question, integral 1 by sin x plus cos x plus 1. Let us solve. Method is same, substitution is same. Put tan x by 2 is equal to t. Then half secant square x by 2 dx is equal to dt. I will directly write dx is equal to 2 dt by 1 plus t square. Now the given integral is I is equal to 1 by, what is sin x in terms of t? 2t by 1 plus t square. Plus cos x 1 minus t square by 1 plus t square plus 1 into dx 2 dt by 1 plus t square. One plus t square cancels, 2 dt by, what is the remaining? 2t plus 1 minus t square plus, here you will get 1 into 1 plus t square. Then t square cancels, remaining is 2 by 2t plus 2. Cancelling 2, you will get integral dt by t plus 1. What is the integral? integral of 1 by t plus 1 is log mod t plus 1. Ln mod t plus 1 plus c. Now substitute t is equal to tan x by 2. Next question. Integral 1 by 3 sin x plus 4 cos x. As usual, we put tan x by 2 is equal to t. I will directly write the further steps. Dx is equal to 2 dt by 1 plus t square. Then the given integral is I is equal to integral 1 by 3 into sin x is 2t by 1 plus t square plus 4 into cos x is 1 minus t square by 1 plus t square. Into dx is 2 dt by 1 plus t square. 1 plus t square cancels. You can take 2 common and cancel 2 also. Integral dt by, after cancelling 2, this becomes 3t, this becomes 2. 2 into 1 minus t square is 2 minus 2t square. It is 1 by a quadratic. How to find the integral? We have already discussed. First we try to factorize. First you take minus common. Always make coefficient of t square positive, that will be convenient. Taking minus common, minus of dt by 2t square minus 3t minus 2. First we try to factorize. If it is factorizable, we can resolve into partial fractions and integrate. If it is not factorizable, then we write it as a perfect square and we get 1 by x square plus a square or 1 by x square minus a square, then integrate. First 2 into minus 2 is minus 4, minus 4 is minus 4 into 1, minus 4 plus 1 is minus 3. So, it is factorizable. What are the factors? You know how to factorize, directly I will write. It is 2t plus 1 into t minus 2. Check, 2t square minus 2 minus 4t, yes, correct. It is factorizable. Then take partial fractions. A by t minus 2 plus b by 2t plus 1. How to find a and b? We have already discussed that method. For getting a, you cover this corresponding factor t minus 2 here and put t is equal to 2 in the remaining. What you will get? 1 by 5. So, a is 1 by 5. How to get b? You close this factor here and put t is equal to minus 1 by 2. If this is 0, t is equal to minus 1 by 2. No? So, close this and put t is equal to minus 1 by 2. Then 1 by minus 1 by 2 minus 2 is 1 by minus 5 by 2, that is minus 2 by 5. So, b is minus 2 by 5. Then write the integral directly. Minus 1 by 5 into integral of 1 by t minus 2 is log mod t minus 2. Next, minus of minus is plus 2 by 5 into Integral of 1 by 2t plus 1 is log mod 2t plus 1 by 2. Derivative of 2t plus 1 is 2, no? So, log mod 2t plus 1 by 2 plus c. 2 cancels. Now, you can simplify further. Taking 1 by 5 common, it becomes log a minus log b, log a by b. 1 by 5 into log mod a by b means this by this, 2t plus 1 by t minus 2 plus c. Substitute t is equal to tan x by 2. Okay? We can also solve this question in a second method. Second method. Integral 1 by 3 sin x plus 4 cos x dx. In this method, we will combine these two terms into a single term. Construct a right angle triangle whose sides are 3 and 4. Let this be right angle triangle with sides 3 and 4. Let this angle be alpha, some constant angle. Then what is the hypotenuse? Root over 4 square plus 3 square, 5. Then 3 by 5 will be cos alpha, 4 by 5 will be sin alpha. So, I will divide by 5 here and multiply by 5 like this. Value remains same. Now, I can write 3 by 5 as cos alpha, 4 by 5 as sin alpha. It becomes 1 by cos alpha sin x cos alpha into sin x plus sin alpha into cos x. Dx. Alpha is some constant angle. What is sin x cos alpha plus cos x sin alpha? Sin x plus alpha. 1 by 4 integral 1 by sin x plus alpha, which is cosecant x plus alpha. 1 by 5 integral cosecant x plus alpha. What is the integral of cosecant theta, cosecant x? Log mod tan x by 2. We have the formula. So, it will be 1 by 5 log mod tan x plus alpha by 2 plus c. But finally, you should mention the value of alpha. Tan alpha is 4 by 3, so we can write alpha as tan inverse 4 by 3, where alpha is equal to tan inverse 4 by 3 plus c. Okay? So, this is second method. Now, in integration of trigonometric functions, model 2, integral 1 by a plus b cos square x, integral 1 by a plus b sin square x, integral 1 by a sin square x plus b cos square x, integral 1 by a sin square x plus b sin x cos x plus c cos square x, c into cos square x, or integral 1 by a sin square x plus b sin x cos x plus c cos square x plus d. For all these 4 forms, 4 or 5 forms, standard method is there. Method is multiply and divide by secant square x. Then put tan x is equal to t. This is the standard method for all these 5 forms. Multiplying by secant square x, numerator will be secant square x, denominator will be a secant square x plus b. Then you can write the denominator in terms of tan x, then put tan x is equal to t, you will be able to calculate. Let us see some examples. Integral 1 by 1 plus sin square x. Let us follow the substitution or method. Multiply and divide by secant square x. Numerator becomes secant square x into dx. Denominator secant square x plus what is sin square x into secant square x? It is sin square x by cos square x. Secant square x is 1 by cos square x, no? So, sin square x into secant square x will be sin square x by cos square x tan square x. Now, we are going to substitute tan x is equal to t. So, you should write the denominator in terms of t. Integral secant square x dx upon, if you write secant square x as 1 plus tan square x, it will be 1 plus tan square x plus tan square x, 2 tan square x. Now put tan x is equal to t. Then secant square x by secant square x dx is dt. Then this will be integral dt upon 1 plus 2t square. It is now in the form of 1 by 1 plus x square. What is the integral? Tan inverse x. You should write 2t square as root 2t whole square dt by 1 plus root 2t whole square. Assume that root 2t is x, its integral is tan inverse root 2t. But when you assume root 2t as x, we have to divide by derivative of root 2t with respect to t. What is that? Root 2. Dividing by root 2, we get 1 by root 2 into tan inverse root 2t plus c. Substitute t as tan x. You will get 1 by root 2 tan inverse root 2 tan x plus c. Okay. Let us see another question. This is also in the form of those standard forms, one of the 5 standard forms. What is the method? Multiply and divide by secant square x. And one more thing is, instead of multiplying and dividing by secant square x, you can multiply and divide by cosecant square x. Then we have to put cot x is equal to t. Multiplying and dividing by secant square x, numerator becomes secant square x dx. Denominator, multiplying by secant square x, this becomes sin square x by cos square x, that is tan square x, plus here multiplying by secant square x means dividing by cos square x. That means you are taking cos square x common from the denominator, then that cos 1 by cos square x becomes secant square x, and denominator becomes sin square x by cos square x tan square x. This becomes 3 sin x cos x by cos square x. What is it? 3 tan x minus 5 cos square x by cos square x is 5. Substitute tan x is equal to t. Then secant square x dx is dt. Then it will be integral dt upon t square plus 3t minus 5. How to integrate now? Is it factorizable? Discriminant is b square 9 plus 20, 29. It is not a perfect square. Discriminant is positive only, but not a perfect square. So roots are there, but they are irrational. So you cannot express it as a product of 2 rational factors. So what is the method? We should write the denominator as a perfect square. T square, write 3t as 2 into 3 by 2 into t. Then we should add 3 by 2 whole square to make it perfect square. What is 3 by 2 whole square? 9 by 4. Then minus 5, we have to subtract 9 by 4. Then these 3 terms will become perfect square. It will be integral dt upon, first 3 terms will be t plus 3 by 2 whole square. What are the next 2 terms? This is minus 29 by 4. It is in the form of 1 by x square minus a square. This is a square. Integral 1 by x square minus a square is 1 by 2a log mod x minus a by x plus a. 1 by 2a means 1 by 2 root 29 by 2. This is a square, so a is root 29 by 2. Log mod x minus a by x plus a. T plus 3 by 2 minus root 29 by 2 by t plus 3 by 2 plus root 29 by 2 plus c. Now simplification, 1 by root 29 log mod, multiply and divide by 2 and directly put t is equal to tan x. You will get 2t means 2 tan x plus 3 minus root 29 by 2 tan x plus 3 plus root 29 plus c. This is our answer. Next example, integral 1 by 3 sin x plus 4 cos x whole square. If you expand the whole square, it becomes the previous form, 1 by a quadratic in sin x and cos x, a sin square x plus b sin x cos x plus c cos square x. So, approach is same. What is the approach? Multiplying and dividing by secant square x or taking cos square x common from the denominator. If you take cos x common from this bracket, when it comes out, it becomes cos square x. 1 by cos square x is secant square x by, what happens to this? We have taken cos x common now, so this becomes 3 sin x by cos x that is 3 tan x plus 4 whole square dx. Now, derivative of tan x is secant square x, so put tan x is equal to t. Then secant square x dx is dt. Then it will be integral dt upon 3t plus 4 whole square. What is the integral of 1 by x square minus 1 by x? Assume that 3t plus 4 is x, any linear term can be assumed as x, and later we have to divide by inner derivative. Integral 1 by x square is minus 1 by x, so it will be minus 1 by 3t plus 4, but we have to divide by derivative of 3t plus 4, that is 3. So, in the denominator we get 3 extra. T is tan x, so it will be minus 1 by 3 into 3 tan x plus 4 plus c. So, this is our final answer. We can solve it in a second method. Method 2. In this method, I will combine 3 sin x and 4 cos x as a single term. How? I have already explained in the previous question. By constructing a right angle triangle with sides 3 and 4, hypotenuse will be 5. You take this angle as alpha, then it will be sin x cos alpha plus cos x sin alpha. 1 by, I will write 3 sin x plus 4 cos x as 3 by 5 sin x plus 4 by 5 cos x whole square. That means I have divided the denominator by 5 square 25. So, I should write 1 by 25 here. Now, assuming this triangle, 3 by 5 will be cos alpha, 4 by 5 will be sin alpha. So, this becomes sin x cos alpha plus cos x sin alpha whole square. Then sin a cos b plus cos a sin b is sin a plus b. 1 by 25 into integral 1 by sin square x plus alpha. sin x plus alpha whole square 1 by, that will be cosecant square x plus alpha dx. What is the integral of cosecant square x? Minus cot x. So, it will be minus 1 by 25 cot x plus alpha plus c, where alpha is equal to tan inverse 4 by 3. Okay. Next, model 3 in integration of trigonometric functions. A sin x plus b cos x by c sin x plus d cos x. For this integral, the standard method is method write the numerator a sin x plus b cos x let the numerator be equal to a into denominator c sin x plus d cos x plus some constant b into d by dx of denominator, d by dx of c sin x plus d cos x. By taking like this, what is this? Numerator is equal to a into denominator. I will write in a shortcut words. Write numerator as a into denominator plus b into d by dx of denominator. Then a derivative of c sin x plus d cos x you can calculate. Then comparing the coefficients of sin x and cos x, you will get two equations in capital A and capital B. By solving the two equations, you can get the values of a and b. Okay. After finding a and b, what is the method? This question becomes, I will write numerator as a into denominator plus b into d by dx of denominator. After finding a and b, this by denominator. Now separating the denominator, we get this by this is a plus b into d by dx of denominator by denominator. A and b are constants, so a into, what is the integral of constant a? Ax plus b into, this is f dash x by fx, derivative of denominator is numerator, no? What is the integral of f dash x by fx? Log mod fx. So we get the answer. This is the standard procedure for this form. Similarly, if you have a sin x plus b cos x plus c, if you have plus c in the numerator plus constant in the numerator plus constant in the denominator, then what we do is we take same a into denominator plus b into d by dx of denominator, you will get plus another constant also. Method is same. By comparing the coefficients and constants, we will get the values of a, b, c. Then dividing the denominator, we have to integrate. Let us solve some questions. One more question. If the integrand is in the form of a e power x plus b e power minus x by c e power x plus d e power minus x, you follow the same method as this first one, you will get it. Okay. Some examples. Integral 2 sin x minus 3 cos x by sin x plus 4 cos x. Let numerator be equal to a constant a into denominator sin x plus 4 cos x. Plus another constant b into, I will directly write the derivative of denominator, cos x minus 4 sin x. Okay. Compare the coefficients. Comparing the coefficients. Coefficient of sin x in the RHS is a minus 4b. A minus 4b is equal to 2. Comparing the coefficient of cos x, 4a plus b is equal to minus 3. Now solve. How to solve? Multiply the second equation by 4 and add with the first equation. Then 16 plus 1, 17a minus 12 plus 2 is minus 10. Then a is equal to minus 10 by 17. And how to find b? b is minus 3 minus 4a. Minus 3 minus 4a is plus 40 by 17. Plus 40 by 17. How much it is? It is minus 51 plus 40 minus 10 by 17. Okay, I think minus 3 minus 4a minus 40 plus 40 by 17 minus 51 plus 10 minus 10 by 17, right. Then the given integral is I is equal to, what will you get? Integral of, if you separate the denominator after writing numerator like this and separating the denominator, this will cancel, a will be remaining plus b into this by denominator. Cos x minus 4 sin x by sin x plus 4 cos x. Integral of a is ax plus b into, this is f dash x by fx. What is the integral f dash x by fx? Log mod fx. Plus c. Okay. Let us solve another question. Integral 1 by 1 plus 2 tan x. If we write tan x as sin x by cos x, what will you get? Write tan x as sin x by cos x and take LCM. You will get cos x by 2 sin x plus cos x. It is in the form of the previous question. Numerator is 0 into sin x plus 1 into cos x. Denominator is 2 sin x plus cos x. So, method is same. Write numerator as a into denominator plus b into derivative of denominator, that is 2 cos x minus sin x. Now find a and b by comparing coefficients. After finding a and b, what is the final answer? Ax plus b log mod this denominator. So you can finish it. The only calculation part is left. Next question. Integral sin x plus cos x minus 1 by 2 sin x minus cos x plus 3. Already I have explained the method. We have to write numerator as a into denominator 2 sin x minus cos x plus 3 plus another constant b into derivative of denominator. What is it? 2 cos x plus sin x plus another constant c. Compare the coefficients now. Comparing coefficients of sin x, 2a plus b is equal to 1. (2a plus b is equal to 1). Comparing coefficients of cos x, minus a plus 2b is equal to 1. Next, compare constants. 3a plus c is equal to minus 1. The solving part of these equations is left to you. So, I want to finish the question, finish the solution in terms of a, b, c. You solve and substitute. What will be the integral now? I is equal to integral. This is numerator. Numerator is expressed like this. If you separate the denominator, this by this is a plus this by this b into 2 cos x plus sin x by 2 sin x minus cos x plus 3 plus c by 2 sin x minus cos x plus 3. This is Ax. What is this? F dash x by fx. Integral is log mod fx. Plus c into integral 1 by 2 sin x minus cos x plus 3 dx. Now, this is in the form of one of the previous models. What is the standard substitution for this model? Tan x by 2 is equal to t. Putting tan x by 2 is equal to t, this becomes 1 by some quadratic in t, you can integrate it. The method is bit long, but this is the standard procedure. You can't solve it more in a more shortcut way. Okay. So, with this integration of trigonometric functions is over. Okay. So, we are going to start the next method of integration in tomorrow's class, that is integration by parts. Okay. And all of you should be very thorough in the formulae, then only you will be comfortable while solving problems. Okay. Thanks for watching.